Salam to all learning fellows. Hope so you will be fine. Okay, today we are discussing about derivatives and we are going to find nth order derivative formulas. So here we discuss the first one, derivative, nth derivative of exponential function whose power is ax. So the formula is a power n, because we are taking nth derivative, e power ax, and the second one is the nth derivative of ax plus b, a linear function whose power is m, but we are going to find its nth derivative. So we just need to start this m comes here, m factorial, then we can subtract m minus n factorial from its denominator, and the linear function as it is, but reduced its power is reduced to m minus n, which is in fraction. And remember that this a, because we are taking as a derivative and we are taking nth derivative, so this is a power n, just like first formula. Okay, third one is nth derivative of 1 over ax plus b. We just need here to memorize the formula minus 1 power n and factorial of n, a power n, just like before, here a power n and here a power nth, because we are taking nth derivative. And we can observe that ax plus b power is 1 greater n plus 1. Okay, and the last one, as the function is power n, but we need to find the nth plus 1 derivative. So after n derivative, the formula is free of constants. So when we take another derivative, then we can see that the answer will be 0. Okay, we don't need to just memorize it, we can understand it also. Just like first formula, we can see the pattern. For example, first derivative we take a power ax is equal to a e raised to power ax. Again we can take second derivative of this function e power ax. So here also differentiate a e raised to power ax. The answer will be a square e raised to power ax. And if we can take third derivative of a left hand side, we can see that the derivative of this function a square e raised to power ax, the answer will be a cube e raised to power ax. So observing that pattern, if there is an nth derivative of this function e power ax, the answer will be, here is 3, then here is 3, here is n, then here is a power n e raised to power ax. So that is the formula one which we need to we can clearly see the pattern. And now we just discuss about the second derivative is related to function is ax plus b whole power m. We need to differentiate it. When we take first derivative, what happened, we use power rule, m at start ax plus b m minus 1, and after that derivative of this function we can get a. So the answer is m a ax plus b power m minus 1. If we differentiate again, left hand side function means second derivative, we need to differentiate right hand side also. And we can observe that when we differentiate it, there is m minus 1 at start, and ax plus b, we can see that m minus 2, because already minus 1, again 1 reduce and minus 2, and this a is again at multiplied with a, so a square, this a is already present, and one more a is multiplied, so we just find that the answer is m into m minus 1 a square and ax plus b power m minus 2. We can see the pattern d, third derivative of x with respect to x, function is same, ax plus b whole power m. We need to differentiate right hand side also, d over dx of a square is a constant, m into m minus 1 is constant, just here variable is ax plus b power m minus 2. So what we get that a square is increased to a cube, here power is at start, and 1 power less in the original function, so m minus 2 m minus 3 instead of m minus 2. So this is the pattern. If third derivative, here third power of a, and m is reduces to 2. If 3, m is reduces to 2, and m minus 3, here 3, if then we can take here also 3. So if we see the pattern, we observe that dn dx power n ax plus b whole power m, and here answer is a cube in an instead of a cube because nth derivative, and we can observe that if here is m, again we can m minus 1 up to m minus n, is it okay, and ax plus b m minus n. So remember that this is we can take when we solve this m factorial over m minus n factorial. We observe that m reduces m minus 1, m minus 2, up to so on m minus n factorial over m minus n factorial. If we eliminate this function, then we can observe that there is again the function of m minus n, the function of m minus n. So the answer will be dn over dx power n ax plus b. This is just the simplification form of m factorial over m minus n factorial, and the function is same as ax plus b power m minus n. So hope so you can understand how that function is deduced from the pattern. Again memorize that we observe the pattern derivative ax plus b whole power m. We first time differentiate, then second time differentiate, then third time differentiate, and we observe the pattern. The pattern was totally clear that if third derivative we can take, then a get power 3 and m into m minus, and if there is power 3, there is power 2 in a coefficient, and ax plus b as it is, we can subtract power 3 from m. So ultimately we get that nth derivative of ax plus b whole power m, replace 3 with n, m into m minus 1 as it is m minus, here is some uh, more correction needed, then here we need n less 1 less than n, 1 less than n, because 2 is less than 3, so here n minus 1 is less than n. So after that we can make a formula of nth derivative a power n as it is, m into m minus 1. We can discuss here that m factorial over m minus n factorial is also same as m minus n minus 1. So that will be the required answer for this question. Now we will do another example, which is the third example, this one, d over dx of 1 over ax plus b, and we first differentiate first, second and third time, and after that we can observe a pattern. For example, derivative of this function is equal to ax plus b power minus 1. We take minus 1 at start, ax plus b whole power minus 1 minus 1 minus 2. So the answer will be minus 1 over ax plus b power minus 2. Also the derivative of this function is a, and we can take here a. Second derivative we can take of this function, so we need the right hand side also differentiate, which is equal to minus 1 into a over ax plus b power minus 2. These are coefficients which we can take out of the derivative, and again we differentiate and get d over dx of ax plus b power minus 2, and after minus 2 taking at start, the answer will be minus 1 into minus 2 into a. 1 is already outside the derivative, 1 is again outside, and multiplied with a, and after power rule applying we can find there is a third derivative, and the answer will be minus minus, it's a plus 2 a square over ax plus b power cube. So here is the third derivative, of this function ax plus b. We need to take differentiation of this function also, right side. So we can observe the previous pattern. 2a square is already out of the derivative. D over dx of ax plus b power is 3, and when we take as a numerator we can take minus 3. The answer will be 2a square, and applying power rule minus 3, a and ax plus b power minus 4. So what will be the answer? So that is the third derivative. Is there any pattern? When we take first derivative, there is minus, second derivative plus, third derivative minus. So it is alternate function. So we, when find nth derivative of this function ax plus b, then we can observe that if there is third derivative a power 3, so a power n. Also fraction, if there is third derivative, here is power 4, so ax plus b whole power n plus 1. And you can observe that there is a minus 1 power n into n factorial, and you can easily observe that uh, 1 factorial is equal to 1, 2 factorial is equal to 2, 3 factorial is equal to 6. And you can see that if we can take fourth derivative, then it will become 4 factorial, which is equal to 24. So here is a minus 1 as a alternate. If first derivative, then minus 1, second derivative even power plus 1, and there is again n factorial. So hope so you can understand this whole situation which we can observe through our pattern. And the last one we need to discuss here, if we observe that the last function, now we are going to prove it. For example, if we can observe that there is a power of let's say ax plus b has power 3, and we are going to take its fourth derivative, what will be the answer? We are observing that first derivative give us 3a into ax plus b, and 1 reduce in the power. If we take second derivative of this function, then we can take here the second again derivative. What we get, this is the constant term, we can shift here, then we use power rule. 2 at start, ax plus b, 1 reduce in power, and the coefficient of variable x, because we are taking derivative at the end also. So this a is at start, this 2 is also multiplied with this 6 into a square, and ax plus b, again we are taking differentiation or derivative of this function. We can take right side derivative. What will be the answer of this function is, because here power is 1, 1 is at beginning, 6 a square, and when we differentiate this linear function, we just observe that there is a function of a into x. So the answer will be 6a cube. And if the fourth derivative, when we take of this left hand side, this one is 3, we need to differentiate right hand side with respect to x, and we observe that there is a constant function, answer will be 0. So if there is power 3 and here is power here derivative is 1 more than this power, then answer will be 0. So clearly we can say that if derivative of a function whose power is n, and we are taking derivative n plus 1, the answer will be 0. Hope so you can understand these four formulas which we discussed today, and hope so you can understand these four formulas. And in next video we will discuss more nth derivative formulas. For today, just do some practices, and if there is any confusion, you can feel free to ask the question. I will try to answer your questions. Thank you so much.